In continuum mechanics, the macroscopic velocity, also flow velocity in fluid dynamics or drift velocity in electromagnetism, is a vector field which is used to mathematically describe the motion of a continuum. The length of the flow velocity vector is the flow speed and is a scalar. Definition: the flow velocity u of a fluid is a vector field which gives the velocity of an element of fluid at a position and time. The flow speed q is the length of the flow velocity vector and is a scalar field. Uses: the flow velocity of a fluid effectively describes everything about the motion of a fluid. Many physical properties of a fluid can be expressed mathematically in terms of the flow velocity. Some common examples follow. Steady flow: the flow of a fluid is said to be steady if it does not vary with time. That is, if incompressible flow. If a fluid is incompressible, the divergence of is zero. That is, if is a solenoidal vector field. Or rotational flow: a flow is a rotational if the curl of is zero. That is, if is an irrotational vector field. A flow in a simply connected domain which is irrotational can be described as a potential flow, through the use of a velocity potential with if the flow is both irrotational and incompressible. The Laplacian of the velocity potential must be zero. Vorticity: the vorticity of a flow can be defined in terms of its flow velocity by thus in a rotational flow the vorticity is zero. The velocity potential: if an irrotational mushroom-tip flow occupies a simply connected fluid region, then there exists a scalar field such that the scalar field is called the velocity potential for the flow.